Imagine an electric hypercar that can zoom past any conventional supercar with ease. That's the vision of Helix, a British electric motor manufacturer that has just revealed a groundbreaking new motor for its upcoming hypercar project. This motor is unlike any other electric motor you have seen before. It can produce a staggering 872 horsepower continuously without overheating or losing efficiency. In this video, we will explore how this motor works, what makes it so unique, and what it means for the future of electric hypercars. The electric vehicle market is booming, and so is the demand for high-performance electric motors. With many electric motor options available, the competition has shifted to the supplier's domain, with each supplier striving to offer the best product on the market. Helix, which emerged from Integral Powertrain in 2022, might not have been a well-known name yet. However, they've unveiled some exciting details about their new electric motor called the REB, based on the SPX 177 design. Although it was designed for use in a hypercar, the specific vehicle it will power remains a mystery. What makes this motor special is its impressive performance despite its lightweight construction. The motor itself weighs just 28 kilograms, and with the inverter added, it reaches 41 kilograms. Despite its lightness, it can continuously deliver a remarkable 650 kilowatts of power, equivalent to nearly 872 horsepower. To put this into perspective, the REB motor has a power density of 23.2 kilowatts per kilogram, which is higher than any other electric motor on the market today. For comparison, the Tesla Model S Plaid has a power density of 10.4 kilowatts per kilogram, and the Rimac Nevera has a power density of 14.1 kilowatts per kilogram. The REB motor also has a peak efficiency of over 97%, which means it wastes very little energy as heat. The development of the motor was led by Derek Jordan-Eiley, who previously worked on Formula One power units at Mercedes-AMG high-performance powertrains. Speaking about the SPX 177, Jordan-Eiley said, "It's small and weighs just 41 kilograms, including the 13 kilograms inverter. It is a 2x3 phase motor, so its current is shared across two inverters, a necessary approach to meet the phase current demands at normal DC voltages at this extremely high power level. Both the motor and inverter have extremely high power density. 6 high-voltage cables connect the inverter to the motor, while an LV connector carries the various control signals." The secret behind the REB motor's performance is its innovative design and engineering. The motor uses a radial flux configuration, which means the magnetic field is perpendicular to the axis of rotation. This allows for a more compact and robust structure than the conventional axial flux configuration, which has the magnetic field parallel to the axis of rotation. The motor also uses permanent magnet synchronous machine (PMSM) technology, which means it has magnets attached to the rotor that create a constant magnetic field. This eliminates the need for brushes or slip rings, which reduces friction and maintenance costs. The magnets are made of rare earth materials such as neodymium and dysprosium, which have high magnetic strength and resistance to demagnetization. The basic principle of PMSM technology is that the rotor and the stator are both magnetized, and they interact with each other to produce torque. The rotor has magnets attached to it, and the stator has coils of wire that carry electric current. When the current flows through the coils, it creates a magnetic field that rotates around the stator. This magnetic field induces a voltage in the rotor, which causes it to spin in sync with the stator. The speed and direction of the rotor can be controlled by varying the frequency and polarity of the current in the stator coils. This is done by using an electronic device called an inverter, which converts direct current from a battery or power source into alternating current with a desired waveform. The inverter can also adjust the voltage and current to optimize the performance and efficiency of the motor. The REB motor is not only powerful and efficient, but also versatile and adaptable. It can be configured in different ways to suit different applications and vehicles. For example, it can be paired with a single-speed or multi-speed gearbox, depending on the desired torque and speed range. It can also be integrated with a cooling system that either uses water or oil to regulate the temperature of the motor and the inverter. The REV motor is expected to hit the market in 2024, and Helix hopes to attract customers from various sectors, such as automotive, aerospace, marine, and industrial. The company claims that their motor will revolutionize the electric propulsion industry and set a new standard for performance and efficiency. Helix initially received a request from an undisclosed hypercar manufacturer, which had specific power goals in mind, including a high peak power output and consistent performance. To meet these demanding requirements, Helix embarked on a mission to design an electric motor with an architecture that minimized energy losses and heat generation. On the testing bench, Helix's motor has shown remarkable potential. Part of their scalable core technology package impressively delivered over 939 horsepower. According to Jordan New Bailey, the mind behind this innovation, it has the potential to deliver even more power, but the company decided not to push it beyond its limits. Achieving nearly 900 horsepower from a single electric motor is undoubtedly a significant feat. To put this into perspective, consider that the Tesla Model S Plaid, known for its performance, utilizes a combination of 3 motors to produce 1,020 horsepower. Even the extraordinarily powerful Rimac Nevera, boasting a combined 1,914 horsepower, relies on robust rear motors that deliver 653 horsepower each, with an additional 2 front motors generating 299 horsepower each. It's worth noting that these figures represent peak outputs, not sustained performance. While Helix's team has worked wonders in motor development, they acknowledge that there are some challenges in other aspects of the powertrain's design. Notably, the battery associated with the electric hypercar weighs significantly more than a traditional internal combustion engine's fuel reservoir. Despite this weight disparity, the design of the hypercar will center around accommodating the battery. Nevertheless, the lightweight nature of the SPX 177 motor offers increased flexibility in placement options, allowing for a lower center of gravity in the vehicle's layout, a factor that can greatly enhance its handling and performance. The customer told us what peak power they wanted and demanded a very high steady-state output, said Jordan New Bailey. Right now, it is tricky to deliver sufficient energy to maintain that level of output, but in time, it is likely to be possible, and the customer wanted to ensure their flagship model was ready for that. In an interesting comparison, Helix highlights the incredible efficiency of their electric motor by drawing attention to the McLaren Artura's powertrain. Notably, Helix's electric motor weighs less than 1/7 of its combustion engine counterpart found in the Artura, all while delivering more power. It's important to acknowledge that the hypercar's battery pack, which this motor will propel, is expected to be considerably heavier than the Artura's fuel tank. Nevertheless, the achievement of extracting such impressive power from a compact and lightweight electric motor like Helix's is truly remarkable. The chief engineer, reflecting on the groundbreaking achievement, emphasized that their team had surpassed their initial power predictions during the development process. What emerged was a machine that not only met, but exceeded expectations. Notably, one of the standout features of this electric motor is its exceptional cooling efficiency. In the world of electric motors, effective heat management is paramount, as excess heat can lead to performance degradation and even damage. The fact that Helix's motor excels in this critical aspect positions it as a notable player in the field of electric propulsion technology. The Helix motor might not be a well-known name yet, but it could soon become one of the most sought-after electric motors in the world. What do you think about this? Let us know in the comment section below.